Of the statistical learning approach to image classification. There we'll be walking through the software, so I just want to walk us through the software. Now, my software, I want us to see the folder. This is running on a cluster. This is a Linux version, unlike the Windows version that we discussed, but it essentially works the same way. Instead of just with that BC in the Linux, you will use the with that shown in the lecture 1. So this is the folder. So in this folder you have, this is the only thing that is needed. I don't think this is not needed. Alright, so once you have that, you specify the full path, and if you run this, it will show you, if you run this command, it will show you the without the ls, it will show you the switches and how it is run. You can see examples of how it can be run, give some information about the usage. Yeah, so the version, how to use it, so you compute, then the options that are there at the end allows you to run multiple instances of the program. So when you put the -n, you use on multiprocessor machines, and this option also generates the seq file for the samples. Okay, so another important switch is the L, which means you generate a large you use a large picture set. If you don't specify the L, we'll see how many picture set, but the total is around 2600. So you can play around that and see to compute the color features. And this is some of the important one. Another important one is the I and the J. Set a maximum number of training samples for each class. This is used if you want to balance it. So it will, so if you use the hash, it will ignore if the number of samples, if it doesn't have up to what you specify. So high, you put this to specify the number of training samples. The J specify the number of maximum number of test samples that you want to use for each class. So those are important ones. The N is like cross-code validation. So when you use the N, it will do it like cross-code validation. The default is 1, and you want to do some cross-code validation. Okay. So those are some common switches that are used there. Okay. So those are the common ones that are being used. So let's see. Now these are the examples. So you know this is for using multiprocessing, and once you specify this, you specify the path to your data set, and it will generate this at the end of the day. So let's me show an example of one that has been computed. I'm going to do all one of the data set that have been computed. So this is a data set. Let me show the original. So this is the original data set. As you can see in the data set, you have that's another important thing. It requires that the data set, the images be in a TIFF format. It works best with TIFF format. So that's that. So once you run the command, what will be the output? So let's see. Once you run the command, let's see one in which we use the large features. So after running the command, you see it generates this file here. So this is the file that you now use for the test. So this file contains all the features. Using the statistical methods, it computes all the features. Okay. Let me see if I am able to open the file. Let's use cat. I've tried that before, but let me see if I can open the file. And it will allow me to open the file. Let's see. Yeah, it does allow me to open the file. So those are the files that have been generated. The features, that's a lot. You see, so those are the features that have been extracted. It doesn't make much sense now, but we see the CSV version in the subsequent tutorials so that we can see how it makes sense. Alright, so that's essentially how that works. Thank you very much, and see you in the next one.